And so science is all about inquiry and investigating and trying to figure things out. It's not about somebody telling you what the right answer is or reading the right answer in a book. So my name is John Duncase. I'm an emeritus professor of science education at the University of Iowa. And so one of the things that we try to do is have our students who are going to become teachers learn a strategy called conceptual change teaching. And what that has to do with is to start with where the students are thinking, what their initial understandings are, and to get them to do an investigation, some hands-on learning, some inquiry-based learning, to get them to rethink that understanding towards a more scientifically accepted understanding. So if a student, for instance, if you get up in the morning and you run across a tile floor, especially in the wintertime, that tile feels really cold to you. If you get up in the morning with bare feet and you run across a rug, that feels warmer to you. So the kids intuitively think that the tile is actually colder than the rug, even though they might be in the same house and the whole house is the same temperature and the tile and the rug is the same temperature. So what we have our students do is they go out and they interview kids out in the school, like junior high school kids, and they ask the kids to actually have different kinds of objects in front of them and to feel those objects. They might have a piece of steel, a piece of wool, a piece of cork, a piece of plastic, and they ask the kids to predict what the temperatures are of those things. And then the kids come and say, oh yeah, well the steel is much colder than the wool. And then the teacher then would say to the child, to the learner, well, how do we find out if that's really true? And the learner would say, well, let's measure the temperature of it. So what you can do is you can actually then take a thermometer and you could actually put the thermometer on the metal and measure its temperature, and then put the thermometer on the foam and measure its temperature, and put the thermometer on the wood and measure its temperature, and you'll find out that they're all the same temperature. And that will challenge the students' understanding of what they thought originally and potentially get them to start the process of rethinking that understanding. And what you want to do when you're doing an investigation is collect data, and that data then becomes evidence for a claim that you're going to make about how that phenomenon works. Data and investigations go hand in hand. And then sometimes what you might do is say, okay, now I think I know how this works, so I'm going to take my tentative explanation, and I'm going to take the data that I've collected about the investigation I've done to get that explanation. Now I'm going to create some kind of a model to see if I can make my explanation work in a different context. And if I can make it work in a different context, that would be supporting evidence to say that my explanation sort of makes sense. You interact directly with the phenomenon. You're not interacting with a book or a video or something like that. You're interacting directly with the phenomenon. And I think that's incredibly important because that's what science is, interacting and studying and understanding a phenomenon.